It turns out that derivatives and antiderivatives have very similar properties. For instance, when we differentiated a variable and it had a number in front of it, we just ignored the number and we differentiated the variable. The same thing is true when you're anti-differentiating. That's what the property number 1 in this table is saying. And also, when we were differentiating sums or differences, we did not need special rules for that. We just did the derivative of the first, derivative of the second, and then added or subtracted in the middle. This is what the second property in this table is basically saying about antiderivatives. So let's take a look at a couple of examples. So for instance, the first one over here says, determine the indefinite integral for 2x5 plus 3x squared plus 4 dx. So how can I use these properties that we just mentioned to do this problem? So first of all, I have a bunch of pluses and minuses or whatever. So the rule is do individual integrals. So do the antiderivative for 2x5 dx, then do the antiderivative of 3x squared, then do the antiderivative of 4, okay? So that's pretty much the rule that we have listed in property number 2. If you have plus or a minus, just do separate integrals, okay? So that's not terribly difficult. Next, we are going to pull the 2 out because it's a constant. The rule number 1 basically says if you have a constant on the inside, you can just grab it and write it on the outside of the integral. So we're going to go ahead and do that. The integral of the first one is going to become 2 x to the power 5 dx. And then the second one becomes the 3 on the outside and x squared on the inside. And finally, the 4, I'm going to go ahead and also grab it and take it to the outside of the integral. So it's going to be 4, antiderivative of nothing. It's just a blank space, and then dx. Okay, so next we're going to go ahead and do power rule. So what is the power rule saying about x to the power 5? How do you anti-differentiate that? Well, again, you add 1 to the power and you divide by the same thing. Okay, so that one is basically finished. Next we have a 3. Then now we have x to the power of 2. What is the antiderivative of x squared? Again, add 1 to the power and divide by the same thing. So far, 2 times x6 over 6 plus 3 x cubed over 3. And finally, we have the 4, and then there's an integral with nothing written inside. So what's the integral of nothing, right? Now, when there's nothing, that means it's just a 1. So think about it for a second. What function do you take the derivative for to get 1 at the end? Well, the function that you differentiate to get 1 is just the function x. The derivative of x is going to be 1, so the antiderivative of 1 is going to be automatically x. Plus c, where c is a real number. So at the end, 2 divided by 6 is going to be 1/3 x to the power of 6. 3 divided by 3 is going to go away. We get x cubed, and then plus the 4x plus c. So the final answer of the problem is that whole thing.